Hello everyone and welcome to Access 2013 Best Practices. My name is Steve Bishop and in today's video we're going to talk about proper table structure. Now proper table structure are a few different components, things like normalization, that is how do you organize your data so that it is much more compartmentalized and each entity has its own table, and then as well as how do you relate those different tables together. Then there's also some of the best practices for how you want to put your data into your database and some of the pitfalls that you can run into as a developer thinking you're being really smart about something, but in fact are actually creating a drawback later on. So let's take a look at some of the best practices that I recommend for developing a proper table structure. So let's say that we have a database that is going to hold different information about books. So the first thing I'm going to do is create my principal table. That is the main object, the main set of entities that this database is going to be revolving around. And that would be books. So I'm going to go ahead and click on the Create tab. And I'm going to select the Table Design button. And if I clicked on the Table button, that's going to give us this little datasheet style view here where I can click on the drop down to add a new field. But you'll see that it's a bit more limited than what the table designer gives us. So I'm going to close this and I'm going to click Create Table Design, and you can see we have a lot more options. We have some field properties sections over here. We've got a property sheet here for the whole table, as well as our field names show us the data type here, which we can easily change, and we can even add a description for each field. So I really prefer this interface over the regular data sheet style looking one that we were just at. So this table is going to contain books, and when we think about the books and the entity of what a book is, we're going to want to attribute it some specific properties, things like the name of the book. Now if I use name as a field name, you'll see that Access kind of doesn't like this, and that's because name is a reserved word in Access. So you really want to avoid using name as a field name. Instead, you want to be a bit more descriptive about what the name is. In this case, since we're going to be talking about books, I'm going to go ahead and change name to title. But really, title isn't descriptive enough either. Now, title is perfectly acceptable, and if you wanted to move on from there, you're certainly welcome to. But I do think it's a good practice to be a bit more specific, because title could be the title of a person, so that maybe they have the title of their job that they have, or maybe it's the title of an automobile. There's a lot of different titles that you might have. So instead of just saying title, I'm going to say book title. And now there's really no confusion. And when we create queries down the road and we want to reference this specific field that belongs to the books table, sometimes it's a little nicer to know that the field name is not just title, but it's actually book title. It makes things easier to read when you're writing out those queries. Now, the data type is short text. And if we go down here to field size, we see that the field size is defaulted to 255. That also happens to be the maximum number of characters that you can enter into a short text field. Now, I can't think of too many books that would even come close to this 255 character limit. So I'm going to change this instead to 50. Now, the key here is that when you're picking a field size for how many characters you want to allow into a particular field, you want to make sure that there is enough space here that all of the books that you might enter into this table won't exceed that 50 character limit. But you want to make it small enough that you're not occupying a bunch of memory or space on your hard drive to store the data. Because even though I may only be using a few characters of that 255 character limit, the memory is still going to be allocated anyway for the full 255. So I'm going to shrink this back down to 50, and we can move on to the next field, which I'm going to say is book subtitle. And the book subtitles are typically quite a bit longer and bigger than the titles. In fact, I'm going to make this a whole 150 characters wide. Now, these are limits of how many characters that you can put into this particular field. And that is a crucial component to making sure that your database runs faster, because you don't want to be eating up all of the memory and all of the disk space. the smaller the amount of data that your computer has to process through in order to find this book title and book subtitle, the faster your database will run. So keeping the field size as small as possible while giving yourself enough room to actually put the full subtitle into it is important to do. One last thing I'll mention about the field size is that if, for example, some book came along that was bigger than this 50 character limit, it's really easy for me to come back into this table and change it to a different size that is larger. However, it is not as easy to go back. If I change this field size limit to 25, but I had already put in a bunch of entries that exceeded this 25 character limit, then that would actually cause a problem where the database would go through and take off, it would chop off all those other characters past the 25 characters. So you never want to shrink a field size down unless you are absolutely certain that no values exceed that amount. And instead, you can always be aware that it is easy for you to expand it to a larger number if you have to. So I'm going to go ahead and leave this at 50. And now we can focus on the next field, which is going to be the book author. Well, let's think about this for a moment. The book author is actually another entity, because an author is simply a person who wrote the book. And since they're another entity, we should probably dedicate a whole table to authors. So I'm going to go ahead and click Create, and I'm going to select Table Design. And now I'm going to go ahead and do Author Name. So going back to not wanting to use the keyword of name, it's perfectly acceptable to use name as long as it's part of a field name and is not strictly the name of your field. So if I tried to leave it like this, I'd once again get the error. But since I'm putting author in front of it, that's perfectly acceptable. Now you may have noticed both on table 1 and on table 2, I'm using this thing called Pascal Casing. That is, the first letter of each word within the field name is capitalized. So book title has a capital B and a capital T. You'll also notice that there is no space in the name of the field. Although Access permits you to put a space in the field names, it is really a bad practice. You want to limit spaces as much as possible in the names of your fields. That's because spaces in VBA code mean something. And when you're writing out in VBA, you're trying to reference to a table property or a table field name that has a space. It can cause problems in the VBA code if you leave that space in there. So we're going to take spaces out of the field names. We're going to use Pascal Casing to give it capital letters for the first letter of each word within the field name. And now let's go back to the table 2 here and examine for a moment what we want to do with the authors table. So right now we have author name, but really we should probably break these things down or break the name down into each individual component. And that's another good practice of normalization, breaking down components into their most finite pieces. Rather than saying one single field that's going to contain the entire author's name, we probably want to do something like this. Let's go with author, prefix, author first name, author middle name, author last name, and author suffix. Now let's go back through our data types and set appropriate ranges for a field size. So author prefix, I think we're good with 10. And a prefix is going to be things like Mr., Mrs., Ms., that sort of thing. And then for first name, we can probably, I think 50 characters is plenty big for the first name. And for the middle name, I don't think anybody's going to get that big. You could probably go smaller if you really wanted to, but I'm just trying to be realistic here. Suffix, once again, that's going to be things like junior, senior, the third, that sort of thing. So field size 10 should be good. And once again, you can see that I stuck to the naming convention with the Pascal casing, and I'm kind of indicating the author prefix. This is the prefix for an author. This is the first name for an author. This is a middle name for an author. That's because just like we had with books where title could be a field name for some other type of entity, middle name, first name, prefix, last name, and suffix, those are all things that could belong to any type of person. So if we had a table that contained employees, well, those employees might have a prefix, first name, middle name, last name, and suffix. Or, if you want customers, if you want to track customer information, they'd have prefix, first name, middle name, last name, and suffix. So really having this author in front of the prefix, first name, and middle name, that just really helps later on, like I said, when we're writing out queries to know precisely which table we're pulling the prefix, first name, middle name, last name, and suffix from. Since I took the author, the book author field basically out of play here, since the table 2, or what's going to be the authors table, is going to contain the author information, I need to get rid of this field that's going to contain the book author, and instead this should be a relationship between the books and authors. I need to establish some sort of relationship between these two tables. And in order for me to do that, I'm going to need primary keys and foreign keys. So for each book, we're going to need to associate an author to that book. So we would want to have a primary key on our author table that I can then reference in the book table that points to that particular author. Now there is a certain way of thinking about creating primary keys, which says that you never want to create more fields if you can use some of the fields that are within your table because somehow they make up a unique key. So for example, prefix, first name, middle name, last name, and suffix, if I use the combination of all 5 of these fields, really the chances of anybody having the same exact prefix, first name, middle name, last name, and suffix are pretty slim. There's not a lot of authors out there that are going to have the same identical field names. So I could make a composite key of these 5 fields, saying that between these 5 things, there's always going to be a unique record with different values in these 5 fields. The problem then comes when I go over here to table 1 and I want to add in my fields that will relate back to the author. So then I would need to have something like author prefix and author first name and author middle name, etc. So I'd need each one of the fields that exists here in my primary key in order for me to establish a foreign key relationship in my book table to that author table. I would need to have a field for each one of these fields that I have here in my author table. Now remember, the goal that we had for these short texts was to limit the field sizes. So in order for me to identify this particular or a particular record in my author table, I would need to have 5 different fields of data, and that's really a total of, I believe it's like 170, 170 characters in this table in order to reference back to the record that's here in this table. So that's really kind of a waste of space. That's a waste of space on my hard drive and in my memory to have this many fields to create a composite key. So rather than do that, it's much better that I instead create a single field that's going to have a unique value for each record. So I'm going to go ahead and go up here to the top, and I'm going to create a new row. And by convention, you want to name this field ID. This is a pretty universal convention. A lot of people do like to do something like author ID, and that's acceptable. But there is, in other technologies, a requirement that the primary key to certain tables must be just simply ID. So just kind of planning ahead here. After all, best practices are all about making things easier for you down the road. If you can leave this field name just simply ID, then if you ever decide to move into any of those other types of application formats, then you'll already have your table structure set up properly to incorporate into those other frameworks. So I would just highly recommend that you leave your primary key field name as just simply ID. And it's a universal thing too. Everybody's going to understand. Any potential developers that come after you will know immediately that the name of the field name ID is the primary key to this table. So the data type is going to be AutoNumber, and AutoNumber is a special incremented, it's an automatically incremented field in Access. So we're going to go ahead and leave this as an AutoNumber, and you can see down here AutoNumber is defaulted to long integer. And in order to create a foreign key that then points back to this ID field, I'm going to go ahead and say author ID, and it needs to be of a type of number. And once again, its field size of long integer needs to match the field size here for ID, or the primary key of our author table. I'm also going to go ahead and say that this is in fact the primary key by clicking on the primary key button, and we're set there. Now I'm also going to go back here, and we should probably do something similar here for our books. We need to set a primary key. And certainly a book title and subtitle could be set as the primary key as a composite key. But once again, I prefer to have some sort of consistency amongst all my tables. So I'm going to go ahead and say insert row ID AutoNumber. Let's go ahead and set this as the primary key. And now we have a primary key for our book table and a primary key for our authors table. And we also have the relationship established here, because now the author ID field is the foreign key that points to the author of the book. So now to finalize this relationship, let's go ahead and save these tables. So I'm going to save table 1 as books, and table 2 we'll save as authors. And to establish that this relationship between the books and authors, let's go to Database Tools and Relationships. And here we have our two tables. So now in order to create a relationship here between the authors table and the books table, I'm just going to drag the primary key of the authors table and drop it to the foreign key on the books table. And you can see that Access recognizes then that we're trying to build a relationship between the ID field and the author ID field. Now we've seen this before, this edit relationships window before in the basic series. But what we haven't gone over is down here in the enforce referential integrity section. So if I select this, you can see that we get a couple of other options. We get the cascade update related fields and cascade delete related records options. This means that if the ID field for an author, let's say author number 2, had its ID value changed from 2 to 10, then what should happen then to the field that contains the author ID? What should happen to the relationship? What should happen to the value that contains that relationship information between these two tables? Well, if I changed it from 2 to 10 for the ID, I also want that author ID field to change from 2 to 10. So I'm going to select Cascade Update Related Fields, and that will update the author ID field if the ID value changes. Now what happens then if I delete an author? So if I'm in the authors table and I delete C.S. Lewis, well, what would we want to have happen here for the books? Well, we could delete the record. So if we said cascade delete related records, that means if I deleted an author from our authors list, it would also delete any books that are associated with that author. Now that's not necessarily something I want to do, so I'm going to leave that unchecked for right now. Then I'm going to go to the join type, and I'm going to say, do we want to either only include rows where the join fields from both tables are equal, or do we want to include all records from authors and only those records from books where the joined fields are equal, or include all records from books and only those records from authors where the joined fields are equal? I actually want to make sure that whenever we write a query, by default, it's going to include all the records from the books and only those records from the authors where the joined fields are equal. That would be the default when we're designing a query. that doesn't mean that it can't be overridden in the query. So when you're actually designing the query, you can change this relationship if you want to. But it won't change the relationship permanently. It only changes the relationship within that query. So I'm going to go ahead and click on the Create button here. And now we can see that we've created a many-to-one or one-to-many relationship between books and authors. I'm going to close this, so closing the relationships. Now let's go back to the design of our authors and our books. So I'm going to throw you a little bit of a wrench here. And some of you may have already thought about this or thought this up, but what might happen, or how should we handle then, if a book has multiple authors? Because maybe there's a book that's co-written. How would you handle that? How would you store that information in your database? Well, you could simply add another book title, book subtitle, with that other author ID. But then you're just basically duplicating data. You're duplicating the book title and book subtitle when it's not necessary. Is there anything we could do with the authors table? Well, not really. I mean, I suppose that we could combine or concatenate author prefix, first name, middle name, last name, and suffix, or maybe add another like a second author prefix or something like that. But you can see that that would become very laborious, and we'd have an authors table with a lot of blank, empty information. So if we had a second author prefix and a second author first name, well, what about those times where we don't have a second author prefix, first name, last name, etc.? That means that these fields that I'm about to put in here would all have empty or null data, but they would still be occupying memory and data space on our hard drive, because those field sizes would be occupying space in our memory and on our hard drives. So we don't want to add any unnecessary fields to this authors table. So we'll go ahead and delete that. So how do we solve this problem where we might have many authors to many books, right? One author might write multiple books, and one book might have multiple authors. Well, that would be a many-to-many relationship, and there is a very special way to handle that in relational database management systems. I'm going to go ahead and create another table, and this table is simply a brokering table, or what's often referred to as a join table, that says I am joining the data between the books table and the authors table. This is where you can go in order to find out what that relationship is between the authors and the books. So the way that you're going to do this is you're going to take the ID from the book, and you're going to take the ID from the author, and you're going to put both of those two pieces of information here inside of our joining table. So we'll say book ID, which is a number, and you're going to say author ID, which is also a number. Now, one thing you definitely don't want is duplicate records. So we could have a book ID and an author ID. Do we want to add another ID field here? Well, that's probably not necessary, because really the book ID and the author ID are perfectly suitable as a composite key. No book ID and author ID should ever exist twice in this table. I may have an author who belongs to different books, but I'm never going to have the same book belong to the same author more than once. Now let's go ahead and save this table. And by convention, the best way to go about this is to name your joining tables as the primary entity, which would be the books table, with an underscore, and then the secondary entity, which would be authors. So books underscore authors. I'm going to go ahead and save it that way. So since my relationship between authors and books is defined in this books authors table, I no longer need this author ID field. But if I try to go and delete this, you'll see that I get an error. You can't delete the field author ID, and that's because it's already part of a relationship. So I need to go back into, I'm going to go ahead and close all of these out and open up the relationships. And I can go ahead and delete this relationship, and now close it and go back into my books table. And now I can go ahead and delete the author ID. So I'm going to go ahead and save this change to my books table and go once again back into my relationships, and we're going to add that new joining table to our relationships chart. And here we can once again just simply drag and drop between all of the different tables. Now I'm going to go ahead and change these, fix these relationships. So ID to book ID, let's go ahead and enforce referential integrity. I'm going to go ahead and say cascade any related field changes. So if the ID for a book changes, that means it's also going to change the value here in the book authors, the book's authors table. And then if I delete a book out of my table, I probably can't possibly have any relationship between the books and authors anymore because I don't have any books by those authors anymore. So that's perfectly fine. I can go ahead and delete the record of my book's authors. I'm not deleting the record out of my authors table. I'm deleting the record out of my book's authors relationship table. I'm going to change the join type now so that instead of saying include only or include all the rows where the join fields from both tables are equal, I'm going to say I want all the records from my books by default and only the records from the book's authors table where the two fields are equal. So I'm going to go ahead and say OK to that and OK. And now you can see we have our one-to-many relationship again, but this time it's a one-to-many relationship to our join table. I'm going to do the same thing over here. We're going to edit the relationship to the authors table. So the author's ID, let's reinforce our referential integrity. We'll cascade those related field updates. And I'm also going to delete the related records. So once again, if I delete an author, I can delete the associative records inside my book's authors, and that won't affect in any way my books table. So this joining table is really an essential tool for proper normalization and planning of your databases. I'm going to go ahead and change the join type also to include all the records from authors table and only those records from books authors where the join fields are equal. And OK, so there we have our new relationship set up here between books authors and our books authors table. Let's go ahead and close our relationships. And now I want to go back into the books and our authors table. So if we look at the books table and we look at the book title, we'll see that we have a bunch of different field properties here for our book title. Now, a lot of developers like to use some of these properties to help keep the data that goes into the tables more uniform, to make sure that people can't mess it up. And I certainly respect that. Having a format and having an input mask help to determine the precise way that data gets entered into your tables. However, I find that these fields are more or less for if you're planning on letting your users enter data directly into the tables through the datasheet view. And I'm going to tell you right now that that is a terrible, terrible idea. I strongly urge you to never, ever, ever let your users go directly to the tables and enter data directly into them. Instead, you always want to provide a user interface through a form or a report. You never want to just simply let the user open the table. That's because it opens yourself up to a lot of mistyped information or deleted information that you don't want deleted, and you may want to be able to set certain circumstances where those items can be deleted or edited. But you can't do that if you just simply open the table up for editing. The user, once they have that table open, has basically free range to do whatever they want in that table. So I don't even really bother with the format or input mask or caption because these fields are more or less for if you're looking here in the data view, which I never let my users do anyway. But there is a default value, and that's certainly acceptable. If you wanted to have some sort of default value, especially for numerical or things like a yes/no field, it certainly makes, so we'll say like sold out, for example, might be a yes or no field. Then a default value of no makes a lot of sense, or a default value of yes maybe, if you want by default the record to automatically default to having sold out marked for the book. But for the actual name of book title, I don't see any reason for me to have a default value, but you can certainly have whatever you want there. Validation rule and validation text are once again things that are typically more for if you're going to allow the user to just simply open the table in datasheet view. Since I don't allow that, I'm not going to need to worry about that until I design my graphical user interface. Do I need to make the book title required? Well, I'd say yes. So it's a good idea to go through these properties and set them for the fields on each field that you create within a table, just to make sure that you are setting these things appropriately. Should the table book title be required? Yes. Allow 0 length, so should I allow them to basically just put in a blank space? No, I don't want to do that. And required, there is a difference between required and allow 0 length. You can, in a short text, you can actually have blank as a value. And blank would still fulfill the requirement of saying that it is required. Okay, because there's a difference between blank and null. So required means I don't allow any null values. Allow 0 length means I don't allow any blank values. So down here into the indexed property, indexed means we're going to actually speed up searches and sorting on this particular field. So for a book title, for example, if we wrote a query that does a search for a particular book title, if we have it indexed, if we have book title indexed, Access will go through and create a special index that helps us, or helps Access identify that specific record for us. And these are things like where clause or using clauses, or if it's a comparison for a join statement like inner joins, left join, right join between tables. Well, book title is something we might do a lot of where searches, because maybe we want to look for a specific book. So I'm going to go ahead and change indexed to yes. And now Microsoft Access, and we'll even say, do we want duplicates? Duplicates okay. No duplicates. I'm going to say duplicates are okay. So this is going to say that it's going to create its own index based upon the book titles, so that if somebody does a search of the books table based upon the book title, then Access will simply use that index of the book titles to help identify quicker the particular record in the books table. So indexes are a wonderful thing, but you don't want to overuse them, and that's because of the other part of what you might have seen over here. An index speeds up searches and sorting on the field, but may slow updates. So if you're doing a lot of inserting or updating of this table, then you probably don't want to have a whole heck of a lot of indexes. You want to have indexes on tables that are a bit more static and don't get changed a lot. Now the Unicode compression property here means that text values actually can be compressed. Now this saves a little bit on space, but it also increases a little bit, just a fraction of the amount of time that it takes, because it has to uncompress the values in the field. So if you're worried about the speed of your application, you can certainly change this to no. But if you're worried about the size that's being occupied on the hard drive, then you want to go ahead and enable compression. So we'll say yes. The IME mode and IME sentence mode is for Japanese, specifically for Japanese entries. So I typically don't have to worry about that, or you probably don't have to typically worry about that. But if you are a Japanese speaker, you may want to look into those things, if you're planning on doing Japanese characters for entry. And then finally, the text align is once again another field that is for if you're looking at the table in datasheet view. So I really don't have to worry about that. So one of the other fields that we may want to put on a book is the cost. So I'm going to go ahead and say cost. Now cost could certainly be stored as a number, and we can see obviously we don't want a long number. We would want to change this to something like a single, a double, or a decimal. Now we can change the precision of a decimal to just 2, which means that it's only going to keep the 100th digit, right? So since cost would be a monetary value, a currency, we could leave the precision at 2 because there's only going to be 2 values past the decimal point. However, I strongly urge you, instead of using decimal and using precision 2, to change this from a number to the currency. And that's because currency is stored as a different data type, which shortens up or kind of makes it so that the memory used for a currency field is a little less than what you would have if you were using decimal. So if we went to number and then decimal. So instead, you want to use currency. That saves it as a format of currency. You can see decimal places is set to auto, but you could certainly have as many digits as you wanted. Beyond that, you could do all the way up to 14 digits, but I just select auto. And you have basically some of the same properties that we talked about in the other field types. You have the captions, you have default values, is it required, should it be indexed, etc. But I just kind of wanted to point out that you want to make sure you're picking the correct data type, the smallest amount necessary to occupy the least amount of memory to store that information for the values in those fields as possible. You remember, the larger you make this short text, the field size, the longer it's going to take for your database to churn over all of the records that are in this database. So if you went, beyond 50, you went to like the 255. And the same thing goes for using the proper decimal type, currency versus, long integer versus integer or byte or single, double, or decimal. All those things, you definitely want to keep in mind that you're using the appropriate data type to limit the amount of memory and hard drive space that's going to be required in order to store this information. Along those lines, I should also bring up the AutoNumber field. By default, AutoNumber has a long integer as the field size, and that's 4 bytes worth of data. That's 2.14 billion numbers, 2.14 billion different values that you can have. And most tables are not going to have more than that many values in there. But you need to understand that with the AutoNumber field, you cannot recover a number. So if you decided to delete record number 1, you could not reuse 1 at a later time. So the AutoNumber is a little tricky in that way, that if you use the long integer, the maximum number of values you will ever be able to put in this table is 2.14 billion values, regardless of how many you delete. Once you delete it, it's still basically a number that is already reserved, and you can't reuse it. So instead of the long integer field size, there is an option of changing this from long integer to replication ID. Now, since it's part of a relationship, it won't let me do this right now, but a replication ID is really a set of randomized alphanumeric characters, similar to a GUI, or a GUID, globally unique identifier. Replication ID is very similar to that. It just creates kind of a randomized set of letters and numbers. And that's actually an AutoNumber. Now, the thing about a replication ID is that it takes up 16 bytes of data for each record, which is 4 times the amount of space required for an AutoNumber. The good news is that you really will there's a low chance that you'll ever run out of number. I mean, the number's astronomical. You'll never collide replication IDs. But with the AutoNumber, once again, you're limited to that 2.14 billion records over the entire course of that table's existence. Whereas with the replication ID, instead, it means you'll never run out of replication IDs. It's just never going to happen. So if you're really concerned that your table is going to exceed that number of records, especially if you're constantly deleting and re-adding records, doing a lot of inserts and deletes on one table, then you would not want to use the AutoNumber. You would want to use long integer, excuse me. You would want to use the replication ID. So that's just something to think about. So let's talk about calculated fields for a moment here. If we're looking at our authors table, and I wanted to say something like author full name, and that took all of the prefix, first name, middle name, last name, suffix, and jammed them together or calculated them into one single field, that can seem like a really good idea, right? It can seem like a great idea to have this pre-calculated field on our table. But I will warn you against doing this. Your calculations should really be reserved to either the user interface, that would be the forms or the reports, or even better, leave them to your queries. Essentially, if you have a calculated field on a table, it's going to need to query the table first before it presents the data. And that means it's going to go through for each one of these records and produce a calculated value for that record. Rather than do that for every single record on your table, leaving it to a query means that you only have to do that calculation usually for the records that you return, which means that your results are going to come back a lot faster. But once you put a calculated field here in your table, it's really there and it's going to run every time that you try to pull information from that table.